In general, the so-called modulated filters as part of a modulated filter bank are defined to have the following general form. So here we will have a window function, not necessarily limited in length. Here we will have a modulation function, for instance the cosine function, and here we have the frequency index. So another example of filters for the so-called cosine modulated filter banks is given here, and we've seen that we can have this window function and then this modulating function, and then with the cosine modulation the resulting frequency response using the DTFT of the filters in the filter bank are given here. So this is the resulting frequency response from these impulse responses given here. Observe that the multiplication in time becomes a convolution in frequency, and also that the delta functions, they come from the cosine term. So we see here that we have a shift in frequency. Hence, modulated filter banks obtain their filters by shifting a baseband filter, h of n, or a window, let's call it h of n, in frequency from -pi to pi. As a result, we need to design only the h of n with high stop band attenuation and perfect reconstruction. As a result of these frequency shifts, we can say that the subbands of the filter bank, they are frequency shifted versions of the window frequency response. And here, for example, is an illustration that we see a frequency response, then we can shift so it keeps the same shape, but we are shifting, for example, for subbands k and k plus 1. In this picture here, we see our signal, and we also see the windows. So the frequency response of a rectangular window function of the DCT is a sinc function. And when we compare to an ideal frequency response of a block filter, we see that it's quite different. So here we have our rectangular window and the frequency response of this rectangular window, which in frequency domain becomes a sinc function. In order to improve the filter banks, we can, for example, make our window longer, or we can also use different window shapes. Some examples that are all based on the same principle of modulated filter banks are the TDAC, or the time domain aliasing cancellation by Princeton and Bradley, the LOT, the left orthogonal transform by Malvar, and the modified DCT by Bernd Adler.